Wind moves across the North Atlantic, in Iceland, in Greenland, along the coasts of Norway. It doesn't just blow. It strips heat from your skin in minutes. Winter gales hit 60-mile sustained.
There's no shelter in the landscape. Treeless plains stretch to the horizon, volcanic rock and frozen earth.
Wood, when you can find it, washes up as driftwood on remote beaches, or grows as stunted birch, barely thick enough to burn. A standard log cabin here, even if you could gather enough timber, would lose heat through every gap and seam. The wind finds its way through anything built above the land. Stone's no better. It conducts cold. The Norse survived here for centuries. Their approach was different. They stopped building on the land and started building with it. They dug into the earth, under roofs covered in living grass. Inside, walls made of soil and turf. Families stayed warm while blizzards erased everything outside. The turf house used the frozen ground as insulation through winters that would kill anyone unprepared. The problem was simple: stay alive through the winter. But nothing about the solution was obvious. The Norse settlements sat in places that offered extreme cold. Wind that never quit, almost no timber, and winters that dragged on for months with barely any daylight. The cold by itself wasn't the killer. Scandinavian homelands and the colonies they planted in Iceland and Greenland saw winter temperatures drop well below freezing. -20 Celsius wasn't unusual, but cold alone is survivable. Wind changes everything. The North Atlantic climate runs on powerful, relentless wind that blows across open water and bare land, with nothing to slow it down. Wind chill turns cold into something that kills. Exposed skin freezes fast. Any heat you generate inside a shelter gets ripped away faster than you can replace it. A structure that works in still air becomes worthless when gales tear through the walls. And the Norse were trying to build in landscapes that had almost none of the resources northern cultures usually relied on: forests.
Iceland's thin birch scrublands couldn't supply timber for any kind of large-scale building. Greenland was worse, basically no native trees at all.
Driftwood washed ashore from Siberian rivers, carried thousands of miles by ocean currents, and people treated it like gold. You used it sparingly. You didn't waste a single piece.
Importing timber from Scandinavia was possible if you were wealthy, but for most settlers it was too expensive and too complicated.
The wood shortage wasn't just inconvenient. It wiped out the most common solution to northern cold: the log cabin. Logs shrink and shift as they dry. Gaps open between them. You could chink the gaps with moss or mud, but you never fully sealed the structure. In the howling winds of the North Atlantic islands, a log cabin would leak heat constantly. You'd need enormous amounts of fuel just to keep it barely warm. Stone was everywhere, but stone alone didn't solve anything. Dry stacked stone walls let wind whistle straight through the gaps. Mortared stone required lime. Even well-built stone structures conduct cold efficiently, chilling the air inside unless you line them with insulation. Stone works as a foundation, as a base, not as the main thermal barrier. The Norse answer came from what they had in unlimited supply: earth, turf. Specifically, the dense, root-bound mat of soil and vegetation that covered the ground everywhere they settled. They wouldn't build log houses or stone fortresses. They'd carve their homes directly from the landscape, wrapping themselves in the living skin of the land. The turf block was the core of how Vikings built warmth into their walls, not mud or loose dirt. Turf cut from the right ground was a composite, soil held together by years of root growth, from grasses, sedges, and low shrubs. The roots formed a dense, fibrous web that kept the block intact, with strength close to modern compressed earth blocks. A well-cut turf brick, sliced from peat bogs or old pasture land, could be lifted, stacked, and shaped without falling apart. The power was in its internal structure. Between every root fiber, Within every particle of decomposed organic matter, there were tiny pockets of trapped air. Air, when it's still, insulates better than almost any solid material. The cellular structure of turf created millions of microscopic dead air spaces throughout its mass. A wall built from turf blocks stacked 3 feet thick wasn't just soil. It was a matrix of insulation that slowed heat transfer down to nearly nothing. Vikings cut turf in standard sizes, usually rectangular blocks about 2 feet long.
The cutting happened in spring or early summer, when the ground had thawed, but before the soil dried out too much.
Workers used specialized cutting tools to slice beneath the root mat, keeping it intact. Each block was heavy,
but 2 people could carry and position it. The construction method was methodical. First came the foundation,
dry stacked stone, laid directly on leveled ground or on bedrock where available. This stone base served multiple functions. It elevated the turf walls above ground moisture, preventing the bottom courses from wicking up water and rotting. It provided drainage, letting water flow away from the structure rather than pooling against organic walls. And it created a stable, level platform that wouldn't shift or settle
under the weight of the turf walls and roof. On this stone foundation, the turf walls rose. Blocks were laid in overlapping courses,
often in a herringbone pattern that interlocked them and distributed weight evenly. The walls sloped inward slightly as they climbed, creating a tapered profile that improved stability and shed rain. Thickness varied by region and period, but commonly reached 1 meter or more.
Over 3 feet of solid earth standing between the interior and the wind outside.
Wood entered the structure as skeleton, not as walls. Internal posts, usually placed in 2 parallel rows running the length of the building, supported the roof frame. These posts carried the weight of the roof, allowing the turf walls to function purely as thermal barriers, rather than load-bearing elements. Horizontal beams spanned between post tops, and lighter rafters ran from the central ridge to the outer walls, creating the triangular roof profile. The roof assembly was layered. Across the rafters went wooden planks or thin poles laid close together. Over this came birch bark, laid in overlapping sheets like shingles, creating a waterproof membrane. Then came turf, thick courses of it, laid with the grass side up, sometimes 2 or 3 layers deep. The turf roof could weigh several tons, compressing the layers below it into a dense, nearly impermeable seal. Its roots knitting together into a living mat that shed rain and snow, while providing continuous insulation. The result:
a typical longhouse might contain several hundred cubic meters of turf, the equivalent of cutting and moving an entire
and reassembling it into a hollow shell designed to trap heat. The wooden frame represented maybe 10% of the structure's mass. Everything else was earth, root, and stone. The house wasn't built on the land, it was built from it.